Okay, so good afternoon, all of you. Yesterday we have started our new topic, that is electric discharge machining. Okay, in short, it is called EDM. Once again, I will start with the introduction of this EDM. So before that, whether my voice is audible at your all end, all of you, okay. Whether my voice is audible? Yes, okay, no problem. So today we are going to discuss a new topic, okay, that is called electric or electro discharge machining, or in brief, it is called EDM. So this machining process, as I have yesterday I have mentioned that this is very popular machining process in the industry. You can take the example of small scale industry or medium scale or large scale industry. So many industrial modules, industrial equipments are available where they can use this electric discharge machining or EDM process. And this EDM process, it is used in industry as like our traditional machining process itself. Okay, so as like our traditional machining process, so like way, this EDM process also in industry they are using. So as name suggests, this process is the thermoelectric process. Okay, during the overview of the all the process that time I have given this electric discharge machining under the thermoelectric process. So please keep in mind, that means that is electric discharge machining is belongs to the thermoelectric process. Okay, so here you can see in this diagram, okay, which is I have shown in this slide, electric energy we are applying. Okay, that means the we have the DC power supply. Okay, pulsing a circuit. You can see here this one or this one. Okay, yesterday I was showing this diagram. Okay, today I came with this diagram also. Okay, for better understanding. So here we are applying the electrical energy. So this electrical energy is in the direct form, okay, and it is used for the removal of the material. Okay, DC power supply, that means the direct form of electric energy is used, okay, for a removal of the material. So as the name suggests, this process it can be used for electrical conductive material only. Okay, your workpiece should be electrical conductive. So this process has a limit. Okay, that means your material should have the at least a small amount of electrical conductive. Okay, that is required in the material. Okay, at least a small amount of electrical conductivity should be there in your workpiece material. Okay, that is the requirement of this process, that is required. Okay, so then only uh, this then only machining is possible using this process. Okay, machining is possible using this process. Okay, so remember, this is second point. The first was the this process is a it is a thermoelectric process, and the second is here the limitation about the workpiece material is that your workpiece should be electrical conductive. Okay, or in your workpiece or that material should have a small or at least a small electrical conductivity. Okay, which is required in your material so that only your machining is possible. Okay, but here we have the open end that any kind of hard material can be machined by this process. Okay, any kind of hard material we can machine by this process. Okay, so irrespective of its hardness, this process, okay, irrespective of the hardness of your workpiece material, this process can be used. Okay, there is no limitation about your hardness, so very smoothly it can this process can machine any material. But only limitation is that, once again I am repeating that, the your work material or workpiece material should be electrical conductive. Okay, now the another the thing is that we know that this when some uh, sparking occurs, okay, between two switches. Okay, yesterday's example I'm repeating. So we know that when some sparking occurs between two switches, between the two switches, then small amount of metal is removed. Okay, so same concept actually it is used in a controlled manner in electrical discharge machining process. So whenever sparking takes place between two electrical contacts, then a small amount of metal is removed from each of these contacts that we know. So this fact was realized, and many attempts were made to harness and control the spark energy to employ that spark energy for useful purpose, that means for machining of metal. Okay, that means whatever the destructive phenomena was there, no, the sparking taking place, and then a small amount of metal is removed from the both the part, that means female and male part. So that destructive phenomena it is used for the controlled manner, that means constructive purpose only. Okay, and that constructive purpose is what, machining of any material, okay, using the same phenomena. Correct. So once again I'm repeating that when sparking occurs between two electrical contact or two electrical switches, then a small amount of metal is removed from each of these contacts. And this fact was realized, and the attempts were made to harness and to control the spark energy to employ it for the useful purpose, that means the for machining of the metal. So this concept actually already known to us, correct? So some short circuit happen in between the switches and spark occur, that generally or in general we know that. Okay, some short circuits occur or happens. Okay, and in between that switches a spark occurs. So because of spark actually small amount of metal is removed on that switches. Okay, and that metal actually melt there. Okay, and then that metal melts there. Okay, so this concept, same concept actually it is used for a machining of metals. Okay, so in EDM process, same concept actually it is used. So in EDM process, normally relaxation circuit is used. In short, or in commonly, it is known as RC circuit. Now I can show the diagram of relaxation circuits. You can see here. This is the uh, schematic diagram of EDM using a relaxation circuit. Okay, that is in short it is called RC circuit. So here you can see electrodes are there, and that electrodes means what, your tool, and this is a workpiece. Okay, so this tools electrodes are there, are actually one is the tool and another is the your workpiece. Okay, so you can see this is a tool and this is a workpiece. Okay, so the both are electrodes. So tool is actually here will act as a cathode, and workpiece will act as an anode, and these two things are actually it is immersed, or this tool as well as your workpiece both are the two electrodes. Okay, that means you can call cathode and anode, and both are immersed into the dielectric fluid. Dielectric fluid. So here you can see dielectric fluid is there. Dielectric fluid is there. Okay, and this dielectric fluid means it is a normal liquid and it has certain dielectric constant. So it is electrical, actually this dielectric fluid means what, it is electrical neutral liquid, and this dielectric liquid is a, once again I am repeating, electrical neutral fluid is there, and it has certain dielectric constant as well as it has certain dielectric breakdown voltage. Once again I am repeating the important point, dielectric fluid or dielectric liquid has certain dielectric breakdown voltage. Okay, now when we are going to apply, or we apply some voltage, or here you can see applied voltage. Okay, that time actually whatever the, when we applied voltage or our that applied potential, when it is greater than this breakdown voltage, okay, when it is greater than that breakdown voltage, then only this flow of current, okay, whatever the circuit is there, no, so then only this flow of current is there through this dielectric, okay. When your applied voltage or applied potential difference potential is greater than the breakdown voltage of dielectric fluid, then only flow of current will possible, okay. Otherwise, if your voltage applied voltage is less than that breakdown voltage, then current does not passes through this dielectric fluid, okay, through this dielectric fluid, okay. Remember this point, okay. You can see here also, okay. So here you can see in this figure now, so again, you can see in this figure here we have the tool, okay, and here we have the workpiece, okay, which has to be machined. This workpiece means all the component which has to be machined by this EDM process. So you can see there is a spark occur here. You can see there is spark occurs in between this tool and between this workpiece, okay. And here you can see the spark occur red color, so that they have shown, sorry, this black spark, and this is spark channel. So this cathode or whatever our tool is there, no, so normally it is connected to the negative terminal of your power supply, okay. You can see tool is connected to the negative that negative terminal of your power supply. Oh, so that only we can calling cathode as a tool as a cathode. Okay, and what are this workpiece is there also, that workpiece is connected to the positive terminal. Okay, so due to that workpiece will act as an anode. Okay, and you know this power supply. Okay, whatever you can see here, power supply is there. Okay, so this power supply through this RC circuit, okay, we have the power supply through this RC circuit, okay, that is relaxation circuit, okay. Now in that RC circuit there is a capacitor is there. You can see that here we have the capacitor, okay. And so when you are applying some DC voltage or DC pulse power voltage, okay, that means this, when you apply this DC power voltage, okay, then this capacitor will charge, okay. I repeat, on you, when you are applying some DC voltage, DC pulse power voltage, so actually that voltage is around 20 to 80 volts, okay. So when you are applying some DC power voltage, this capacitor will charge, and after that this capacitor discharges, okay. So this capacitor in that RC circuit, it charges, and whatever this charge voltage is there, no, so it discharges through your that dielectric, okay. And the discharging will happen in between this your tool and your workpiece, okay. Once again I repeat, when you apply some that voltage, okay, power sub DC powers pulse power voltage, that time your capacitor will charge, okay. And when your capacitor discharge, no, so that discharging will happen through the through this dielectric, okay. And where it happen, in between this your tool and your workpiece, okay. And while it discharging, this sparks, okay, you can see here, okay, while discharging of the capacitor will, you know, so that time the spark will occur, okay. Now where occur, at a minimum resistance, okay. Wherever the distance between the your tool and workpiece is less, so that point your resistance to the electrical conductivity or electric flow, so that will be minimum, and that point only your spark will happen. So that discharging, during that discharging, spark will happen at minimum resistance. So minimum resistance is there where there is a inter-electrode gap, where is a minimum inter-electrode gap will be there. Okay, minimum inter-electrode gap. Okay, this is whatever the gap is there, no, in between your tool and workpiece. So where that gap is minimum, so in that gap, during the discharging, spark will happen due to the minimum resistance. Okay, so you can see on the workpiece surface, you can see here, here also, you will see that tool also under microscope. If you see, no, okay, this is enlarged view, you can call under microscope view, or this is enlarged view. Okay, or okay, which is I have shown the undulation here also. Okay, I have shown the undulation here also, here also. Okay, you can see. So in that surface undulation, where that minimum distance is there, no, whereas minimum distance is there, no, so there, there the sparking occurs, okay, with the minimum resistance. Okay, and this spark occurs with it follows through the minimum resistance between this tool and workpiece. Okay, so it is the that whatever the gap is, so that smallest gap between that IJ. Okay, normally it is called inter-electrode gap. Okay, so that small gap between your tool and workpiece. So wherever that, less or small gap is there, no, so that time your resistance will be minimum, and during the discharging only, the discharging only spark will occur. Okay, so this how the spark occurs, that I have explained. Okay, now, so this is an explanation about the how this spark occur. Now again, in that, when this capacitor charges, no, okay, you can see here, when this capacitor charges, so after charging it discharges, correct, and it applies huge potential in between this your tool and your workpiece. That means your cathode and anode. Okay, once again I repeat, when this capacitor charges, so after charging it discharges, correct, and during that discharging it applies a huge potential in between this your tool and your workpiece, that means your cathode and anode. So this electrons from cathode, you can see here also. So this electron from cathode break loose from the cathode. Okay, electrons, you can see, as we know that electrons are the negative. So they will attract towards the positive, means anode surface. So when that discharges, capacitor will discharge, no, so that time it applies huge potential in between this your two cathode and anode. So these electrons from your cathode, you can see the electrons are there here. Okay, so these electrons from the cathode break loose from that cathode or from your tool, and it attracts toward the your anode. It attracts toward the anode, you can see the cathode, okay, that dot, okay, black dot. So it attracts toward the anode, or to the opposite charge of uh, attracted. Okay, that means towards the your workpiece or towards the anode. Okay, which is positively charged. You can see the positively charged, this ion. Here you can see the electrons are the negative, correct, and your ions are the positive. So electrons will attack towards the your uh, anode, that means you are towards the your workpiece, correct. So there is a thousands of electrons will be there, which break loose from your cathode, and it directly towards the your anode with a very high velocity, correct, with a very high velocity. So depending on the potential you are applying through this RC circuit, so depending on the capacitor discharge voltage, so this velocity depends on that how much potential you are applying between this your cathode and anode. Okay, between this your tool and anode. Okay, so while coming to this travel through this dielectric, Okay, so this electrons actually it collides with the neutral molecule. You can see it will collide to the your neutral molecule. You can see these are the neutral molecules. So once again I repeat, while coming to this travel now, okay, this through this dielectric fluid. So your electrons actually it collides with the neutral molecules of or neutral atoms of your dielectric fluid. So when electrons, when it collides, so that time this electrons comes outside from the neutral molecule, comes outside from your neutral molecule or neutral atoms of your dielectric. So still more number of electrons actually coming outside. So many electrons actually collide with the dielectric atoms, and electrons this electrons actually comes outside them from your atoms, correct? So that time there is a sludge of flow of electrons from cathode towards the anode, and at the same time these ions, okay, which is positively charged, you can see these are the ions, okay, which are positively charged. So it is these ions are actually directed towards the that anode. So there is a ionization will takes place. So there is a huge chunk of ionization is there. You can see here also, as well as here also ionization, here also you can see here. So huge chunk of ionization is there. So electrons coming break loose from the cathode is coming towards the anode, and ions directed towards the anode, related to anode. So there is a heating of electron by these ions to the cathode, and these electron hitting of electron with a very high velocity to the your workpiece will be there. So when your applied voltage from this RC circuit, when it will more than the breakdown of your dielectric fluid, then actually there is a spark occurs. So this spark is nothing but the this flow of this ionization of this electrons, or hitting of electrons towards this anode, and hitting of ions toward the this cathode. So you can see the ionized column I have shown here. Okay, that means hitting of anode, hitting of the electrons toward the anode, and hitting of ions toward the cathode. Okay, you can see. So this is so whatever that displacement of travel is there, no, so that happens in that column, that is called ionized column. Okay, so these huge flow of electrons are there in that ionized column, and due to this huge flow of ions are there, no, so when it hits, then within a small time, maybe thousands of second in a microsecond time, so this sparking will occur. Okay, so because of this sparking occurs, this molten metal, okay, this when this sparking occurs, no, into very small gap or very small area, into the, you can consider in micron also, small micron, so micron area. So this sparking occurs through, because of this sparking only metal is there, no, on or metal from your workpiece, it start melting, that workpiece surface melts and vaporizes, and at the same time, because of this heating of ions, also material from the tool also melts and vaporize. Okay, but whatever the melting of the material from your tool is, so that is negligible. Okay, so there is a machining, that melting and evaporation of the workpiece surface is there, no, so we can call, there is a machining occurs. Okay, that means uh, removal of the material will take place. Okay, I once again repeat that there is a machining will be there from your tool as well as workpiece, but whatever the amount is there, no, the material removed from it, that is negligible. Okay, and because of this machining or this melting, okay, huge amount of heat is generated there, huge amount of heat will generated there. So because of this generation of this much of heat into that very small area, we are considering only for example only a single spark, we are considering into the small area. So that time also huge amount of metal is molten, and then it comes into the molten state or it comes into the vaporized state. Okay, so this much metal is removed from your workpiece surface. You can see here, or here also you can see. Okay, in this manner, here craters is that is the molten. So this much metal is removed from the workpiece surface because of this huge, or because of the huge heating of friction. Okay, so it forms some craters from your workpiece. So you can see in this diagram I have shown that craters. So this, you can see the this is hemispherical craters are actually generated because of this single spark. Here also you can see how in this diagram also. Okay, because of the single spark from this crater height is whatever I have shown is very less. Okay, maybe that crater height. Okay, here you can see this crater height here, uh, or you can call this. Due to the single spark, this much crater height is achieved, and it is very less, maybe 1.2 to 1.5 micron. And the this depth is there also, that diameter of the your crater is maybe near about 10 micron. This diameter of crater, this, okay, maybe that 10 micron. Okay, so I was telling about the this crater. So this is a crater and this is a shape. You can see. So this much of small craters are generated for a single spark. Okay, for single spark, this much crater, 10 micron, for example, around 10 micron crater is generated for a single spark. So when thousands of spark will generate now, or that when thousands of spark are generated in a 1 second, because we are applying the power supply with 5000 hertz frequency. So that means this 5000 spark are generated in 1 second. So due to that, so many craters are generated on your workpiece surface, just okay, below your tool, because there is a interrelated gap is there. So below your tool, that thousands of or many craters are generated. So these craters are actually distributed over the workpiece surface. Okay, and where that minimum distance or minimum gap is there, no, so it between that distance, that crater will distribute. Okay, so these craters are distributed over this all your workpiece. You can see over this all your workpiece surface. Okay, so just a below your tool. So, and the most important thing is that whatever the replica of the tool is there, no, so that the same replica of tool is generated into the your workpiece surface itself. Okay, whatever the replica of your tool shape is there, no, so the same shape or same replica will be generated into the workpiece surface itself. So this, because of this EDM process, you will get whatever the tool, uh, depending on your tool or tool specification or tool shape, so same shape will be generated over the workpiece surface. So due to this advantage of this process, so any kind of complex shape can be generated using this process. Any kind of complex shapes can be generated by this EDM process. So this tool and workpiece, both everything is actually it is immersed. Once again I'm repeating that both your tool as well as workpiece, both is actually it is immersed into the dialect field. So this machining actually it goes on into the inside, means the total tool and your workpiece, everything is actually immersed into the dialect fluid. Okay, so machining occurs inside the dialect fluid only. Okay, so the relaxation circuit, as I have mentioned, it is called RC circuit, and it is proposed in which your electrode, that means tool and workpiece, are both are immersed into your dielectric fluid. Okay, so this dielectric are normally whatever the dielectric fluid we are using. No, here you can see this dielectric fluid, or here also, or here also. So normally whatever the dielectric fluid we are using, no, so normally they are kerosene and are as well as sometimes um, the that ionized deionized water are also used, but keep in mind that kerosene is used, okay, as a dielectric fluid in case of the your idiom. Okay, so you can see here, okay, dielectric fluid is there, dielectric fluid, this one also, or here also dielectric fluid. Okay, so this tool and workpiece both are actually multiplying that your pure. Okay, so when the spark will occur, that time you will get the ionized water or the spark channel. Okay, so the total channel of that ionized channel is there. No? So that is the total your spark channel will be there. Now, when one spark will generate, so the due to the single spark, okay, so the material will be molten and vaporized, so you will get the vaporized material. So this kind of craters, okay, whatever I am showing here, okay, so this kind of craters occurs, okay, on your the surface of your workpiece, okay. And whatever the zone I have shown here, that ionized column, it is also you can call ionized column is there. So after every spark occurs now again, after that sparking, once again your capacitor, whatever the capacitor I am showing here, once again this capacitor charges, and then once again discharging charges. Okay, so that discharging charging will takes place. So there is a on and off time will be there. Okay, which will affect your performance of the your EDM process. So during off time there is no machining occurs. Okay, during off time there is no machining. So immediately around that zone where sparking occurs, no, so deionization occurs immediately. Okay, during the off time. Got it? So now I request all of you, please draw this diagram and this one. This is very important. I will give 2 minutes to draw this diagram. Please draw, this is very important. So now I think today I have given the satisfactory explanation. Okay, am I right or wrong? Please say yes or no in chat box. I will check. Understood or not? Okay, whether this working principle, sorry, this how sparking is taking place and how metal is removed from the this, whether you got or not one. Please draw this diagram, all of you. Okay, so now let us move for next one point. So, using this EDM process, many things can be done. Okay, so there are different varieties of work can be carried out by this EDM process, and these process actually we have to control in such a way that whatever the your tool wear rate is there, no, so that should be minimum as possible. Okay, whatever your tool wear rate is there, because as we know that during the sparking, the material from the both, that way your tool as well as the workpiece will be removed. But whatever the material is removed, or quantity of or amount of material is removed from your tool, it is very less. Okay, so that tool wear rate, that should be minimum as possible. Okay, so you have to control that, control the parameters of this EDM process in such a way that whatever the tool rate is there, no, so that should be minimum as possible. Okay, so we want more machining, so we are uh, whatever the material removal is there now, so that will take place from your tool as well as the workpiece. But we do, as we know that we do not want to remove any kind of material or material from your tool. Okay, so that care we have to into we have to take care of that one. Okay, so we want to uh, remove more material or maximum material from your workpiece. That means we want maximum material removed from the workpiece itself. So we have to reduce the tool wear rate. So for reducing the tool wear rate, you have to choose perfect tool material, correct, and you have to choose the optimum process parameter so that this tool wear rate can be minimized, correct. So these are the different process which I have shown here. No, so these are the different processes which can be done by this EDM process. So you can see, so that by syncing by EDM is there. That means total tool, actually tool which is the replica of the workpiece, so should be there. No, that replica of the your workpiece to be made on your workpiece surface. Okay, so it is called syncing by EDM process. Whatever the tool is there, no, so tool will be your replica of workpiece. Okay, that we have to make. So this tool, actually it is moving down towards the workpiece, and the same replica is generated from the workpiece, from your workpiece. Okay, so it is called, actually it is called syncing by EDM. Also, we have the another name for it, which is called die syncing EDM process also. Okay, die syncing process. And the second type of EDM is that it may be drilling by EDM process. You may drill a circular hole, you can drill a square holes, or any kind of hole you can drill. Okay, so that is called the drilling. So based on your shape of the tool, same shape holes will be generated into the workpiece surface. And the one another one is the die sinking idiom. Okay, that I have told. Okay, the drilling and die sinking idiom. Okay, whatever the shape we want, whatever cavity we want on workpiece, the same replica we have to first we have to give on the tool, and using that replica of the tool, okay, you have to make on your workpiece. So that is called sinking, and in that you can go for drilling, or you can go for the die sinking also. So that another one is called the die sinking idiom. Okay, so this sinking, so of idiom process are there. Then we have the another type of idiom, that is a cutting by idiom. Okay, so these are the actually sub processes of the idiom. Okay, so cutting by idiom, it is also you can do. That means you can cut the material so by using this idiom process, or you can slice, or that slicing by idiom with a rotatory disc, that is also possible. So you can see slicing by here I have given type slicing by idiom with a rotatory disc, then slicing by idiom with a ribbon or blade, and last one is a cutting by EDM with a wire. Okay, so as I have mentioned, you can use the rotating disc, metallic tool. Okay, this type material. So using that metallic tool, you can do the cutting operation also on very hard metal. Okay, suppose there is a very hard metal is there, and you have to cut the exact required portion. Okay, so this kind of slicing by idiom operation you can do using the rotary disc type. This rotary disc type tool. And another, as I have mentioned, that slicing by idiom by a ribbon or the blade. So you can buy a ribbon or blade, you can do the slicing operation. Okay, and the third one is the cutting by idiom by wire. So you can use a wire also as a tool, and you can go for cutting. So this, what are the wire we are using? So this wire you can use for cutting operation. Normally it is called wire cut idiom. That this wire cut idiom process we are going to see separately, okay, in detail. So this wire you can use for the cutting purpose, and that wire you can move also. So while moving, you have to do the flow of that flow fluid in between your that gap, that is called interlude gap, and you will do the machining operation. You can you can perform machining operation. So that time, what are the wire will be the nodes that will act as a cathode or tool. Another the type of idiom is that the grinding, depending on the grinding. So grinding by idiom operation, that is also possible. So in that again, grinding slicing by idiom with a rotary disc grinding tool, that is also possible. Then slicing by idiom using a ribbon or blade, or cutting by the wire, that is also possible. So what are the grinding operation is there also, that grinding using a ribbon or blade, or cutting by the wire, that is also possible. So what are the grinding operation is there also, that grinding or what so these are the different operations, or we can call the types of the idiom, okay, which are possible using this idiom only. Okay, so I think this much part is understood by you also. Okay, have you got today's explanation? पृथ्वीराज पवार, कोडक, रोहन, वासुदेव, समजलंय का नाही भावनाचं? The remaining part, that setup and other things, we will discuss tomorrow, because today we have covered that introduction and how the sparking is taking place, okay, and how the material is removed, that we have seen. Okay, tomorrow we'll see, we'll start with the setup. Now, uh, I request all of you, please write down your roll number in the chat box so that I can write your attendance. Okay, please write down your attendance, and then only you can leave the this meeting.